Hi, this is Andrea Hendricks. Let's talk about how the graphing calculator can be used with quadratic functions. Specifically, you need to be able to graph a quadratic function, identify the key components, that is the x-intercepts, the y-intercepts, and the vertex, and also set an appropriate window to view a comprehensive graph. So let's begin by graphing these quadratic functions and trying to find all of those key components that I just mentioned. So if we take a look at y is equal to negative 2x squared minus x plus 3. Now, one thing I've left on here on the calculator, do you notice that my plot 1 menu is highlighted? That's because I had entered some data points and was graphing those, and if I don't turn that off, then I get an error message whenever I'm trying to graph. So I need to go up to that plot menu, press enter, and that toggles it off. Now I can enter this negative 2x squared minus x plus 3. And I forgot what window I'm in. Let's just begin in the standard window. So I'm going to press zoom and 6 to get to the standard window. And I see a comprehensive graph for this particular function. So if I want to identify the key components of it, let's talk about how we could do that. First off, if I wanted to find the y-intercept, I mean, you could certainly plug that in and figure it out. It should be 0, 3, right? Well, the y-intercept is pretty easy. I can press trace, and actually it always automatically begins at the y-intercept, so it's the 0, 3. So our y-intercept is 0, 3. Now what about the x-intercepts? Yeah, the x-intercepts are our zeros, so we would actually have to do some computation to find those. We could press second and trace and 0. And you have to keep in mind which one you're finding first. So if I'm going to find this one over here, I'm going to have to be to the left of it somewhere, so I press enter. And then I've got to go to the right of that 0 and then guess. So see, 1, 0 is 1, 0. I do that again to find the other 0. So now my left bound is on the other side of this x-intercept. Press enter. And my right bound somewhere slightly above it and to the right, and my guess. So that one is negative 1.5, 0. Now if you wanted to find out what that actual value is in a fractional form, you probably know that right now it's negative 3/2, but let's say you didn't. What you could do, if you press quit, so second and mode to quit, and then press X and enter, and it will display that value of x that we just computed. And then go to the math menu and press option 1. Oops, didn't do that right. Press option 1 and enter. And it tells you what that is in a fractional form. So we can also write that as negative 3/2, 0. Okay. Now, the vertex is the next key point. So let's go back to the graph and talk about how to find that. So we need to find this highest point. So we press second, trace. The highest point is a maximum point, so we choose option 4. Now we've got to do the same thing, be on the left side of it and on the right side of that point, and then we guess. So here is our maximum, or our vertex point. It's negative 0.25, we'll round to, and then 3.125. Now if you wanted to, this is what you could do to compute this value. Go to, in terms of a fractional form, let's go back to x, press enter to get that to display, and if it can be displayed as a fraction, we will see it here. We press math and choose option 1 and enter. Okay, when that happens, that tells you that there is no fractional form for this decimal. which means that that is an irrational number. And so you would just have to then approximate it to however many decimal places you're told. Okay? So everybody remember, so y-intercept is when we press trace, it automatically begins there. X-intercepts, you have to use the 0 function, which is from second trace. And the vertex, in this case, we had to do the maximum, which was at second trace. Now, let's look at the other function that I have listed here. 4 times, in parentheses, x minus 5 squared minus 7. Okay, so the components of that graph are shown in this standard window, but we do need to find the y-intercept, x-intercept, and vertex. Oh, I said that incorrectly. I'm missing one, right? The y-intercept is actually not shown in there, so we would have to reconfigure our graph to find out a window that would show that. So let's talk about the y-intercept. See what happens when we press trace. You see it says 0.93. So we'll talk about just in a minute how we can reset the window to see that point. Let's do our x-intercepts. So we would go second trace, choose 0. Left bound is 0.93, so it's somewhere to the left of this point. We can pull it down so that we can actually see it a little bit better in our window. Should be coming into view here. Okay, so here's a left bound, a right bound, and then a guess. So that x-intercept is 3.68. Computing our other one, second trace, 0. And just moving to the left of this point, and then the right, and now guess. So that other x-intercept is 6.32. Now what about the vertex point? We can do second trace. Now keep in mind this is a parabola that's opening up, so that vertex is a minimum. So we've got to be on the left side of it. If you think about that imaginary axis of symmetry running down through the vertex, you want to be on the left side of that axis, and then the right side of the axis, and then guess. And it doesn't really matter how far to the left or right you go. You don't have to go crazy with that. And then press enter. So our minimum point would be 5, -7. Okay, and we know that because of this vertex form that we're given. Now let's talk about the window. That's really on my next slide, but we'll go ahead and talk about it here so we can see a complete graph. We know that our y-intercept is 0.93, so whenever we're looking at the window settings, the only thing we need to change is the maximum y value. So if it is at 93, we would probably put in 100 here. And to count up to 100, maybe we count by tens. And now graph. So there we can see a complete graph. Now let's look at this, which is one of those applications dealing with height of an object that's propelled upward. And if we wanted to determine an appropriate window to view this graph, let's look at it in the standard window first. I'm going to go back to Zoom 6 and change this function for just a minute here. So we have -16 x squared plus 80x plus 100. And if we graph, we do see our x-intercepts, and we're missing our y-intercept and our vertex. We know the y-intercept is 100, right? If we plug in 0, we would get 100. So let's see what happens if we change our largest value of y to be maybe 150, just to be something larger than the 100, because the vertex is going to go up to some point and then come back down. And let's say we're counting by 10 still. Okay, so 150 was not large enough to see what that highest point is. Let's see if we can determine what the highest point is from the table of values. My table's at 30, so let me reset this. So I do second window. I'm going to start my table at 0, and the change in table is going to be 1. Now we can go back to second graph. Okay, so do you see I have some values in here that are 196? Looks like it goes up to 196 and then coming back down. So in between 2 and 3, it reaches the highest point, and then that symmetry is occurring on the other side of that point. So going back to my window setting, instead of 150, let's perhaps try 250. It needs to be something larger than 196. And maybe we count by 25 to get to 250. And now graph. Yeah, and there we see it. So did you see the process that I went through? I looked at what was the largest y value recognized by the y-intercept. That didn't give me a large enough window. So then I went to the table to view if I saw any values of y that were larger than the 150, and I did. And that's allowed me to set my window appropriately. It sometimes is a guessing game. I know you might think that, and that's exactly what I was trying to do. Think about what are appropriate values that make sense in this context. Now, if I wanted to identify that vertex point, let's just go through that again. I can go, because this would actually help you if you're trying to find the range of this graph, right? If I do second and trace, and that is definitely a maximum since the graph is going down, and I need to be on the left side of that, and then on the right side of that point, and then guess. So my maximum is 2.5, 200. So what would that tell me about the range of that function? We know the domain is all reals, right, because it goes indefinitely from left to right. That's true for any quadratic function. But the range is not all reals, so we're reading from bottom up. So the bottommost point is negative infinity. To the topmost point is 200, right? It's the y value of the vertex. Okay, so I had to start with my y-intercept, and I was a little larger than that. Since that didn't work, I looked at the table, and I found values of 196, and then I was slightly larger than those largest values that I saw in the table. Okay, so if you have any questions about how to graph quadratic functions or set the windows, please contact me. Thanks.